what type of questions do we refer to as time and work types? Right, so just take a very simple example. There is person A who can do a piece of work in 10 days, and there is person B who can do the same piece of work in 20 days. How many days will A and B together take to complete the work? That's the very skeleton level question that you can think of in this topic. Right, so there is some work to be done. We'll talk about different people who can complete the work in their own speed, and then we'll ask you to answer required quantity. So there are slightly 3 to 4 ways. I mean, they're almost the same methods, but there is slight difference in each of this. We'll cover the one which we prefer. I'll also talk about the other methods briefly. If you have the tendency to use that because of your past experience or your own preferences, go ahead and do that. Right? The way you take will not give you any different answers for these type of questions. Right? So the biggest assumption we make in this question is this, that we'll assume some total work. That is, as I said in this question, I said A can do a piece of work in 10 days, B can do a piece of work in 20 days. There is no quantity or quantification of the total work. What do you mean by work? I mean, work could be like building a wall, building a bridge or something, that's fine. But what do I mean by completing it? Like, is it that we need to build 100, a building worth 10 floors, 100 floors or something like that? There will be no quantification of the work. So we can always assume that. It will always help us to get the answers in easy numbers rather than some variables. So my starting point would always be assuming total work for most of the questions. So what should I assume? That is gonna depend on what sort of information is being given. We can assume the total work to be 100, 10,000, 1, 2, 3, 4 or anything you want. The answer will not change. It's just that the calculations will be complicated or easy depending on what we assume as the total work. Right? But just keep this in mind that for time and work questions, the total work will never be mentioned as a quantity. We can always assume the total work some number and go ahead and solve the question and get the answer. It will never give you a wrong answer irrespective of what you assume and whether I can assume or not. That's a key point to be noted from this part. So what should we look for while solving a problem? There are 3 variables that we should be understanding: work done, work rate, and time taken to complete the work. Generally, the question would be giving you a couple of things and you should be using them to find out the third one. Sounds as simple as it, but you have to figure out what is being given and what are the given values and then accordingly find the required one. So let's assume that there's a person A. Work rate is basically per unit time, how much work will this person do? Work done per unit time. To make things easy, right, what I would always prefer is let's take the work done units as bricks. So I'll complete a piece of work if I put 100 bricks. Let's assume that. Right, if I put 100 bricks together, I have completed the work. So the work rate would be how many bricks would a person put, let's say, per day. It could be per hour, per minute, per week, depends on how the information is given in the question. But just stick to an example like bricks per day. Let's assume that a person can put 5 bricks per day. Right? So the work to be done is 100 bricks. If a person can put all 100 bricks together, he has completed the work. And his capacity or his work rate is basically putting 5 bricks a day. So how long will it take? Time taken to complete? As I said, his work rate into time taken to complete is the work that will be done. So 100 bricks. Right? So time taken would be 100 by 5. That's basically 20 days. So the person will take 20 days. Right? The formula is this: the work done equals to the work rate into time taken. So always that we'll know a couple of things, like how I know work rate and work done. I found out the time taken. That is how the questions would be framed. So the very important part is this: you have to be able to differentiate what's given and what's not given. So work done, as I said, is work to be completed or work that is there in the hand to do, and the units would generally be, let's say, like bricks or something. You won't find these units anywhere. These are not SI units, standard units. These are just an assumed units that I prefer to use to explain things. right? So that means if I say, if I put 50 bricks, the work is done, that's basically the work done. The work rate is how many bricks are, a person can put, the person we are referring to, in unit time, per day, per hour, per minute or something. I don't know what the unit time, it depends. Accordingly, the time taken would also be calculated, right? In days, hours, minutes, right? It is basically saying if the person works at this rate, these many bricks per day, he will take these many days to complete this many bricks. So the relation is work done is equals to work rate into time taken. It's just that identifying what is being given and what's to be done so that you can solve the question. So let's take a simple example. There are 3 people, A, B and C, who can do a piece of work in 10 days, 15 days and 30 days respectively. They began the work together to complete the work. In how many days was the work completed? So they gave individual information. There is person A, person B and person C. The number of days they take to complete the work is 10 days, 15 days and 30 days. So they are asking how long will they take if all 3 of them work together. So I need to find out the time for them. So as I said, we'll assume the total work. That will be my first step. What should I assume the total work? 100, 10, 50? So the logically easiest way is take the LCM of the overall time taken by the given entities. That is 10, 15 and 30. What is 10, 15, 30 LCM? That's 30. Why did I take 30? I'll show it. First, let's go ahead with this example. 30 bricks, let's assume to be the total work. The total work will not change, right? All of them are doing the same work. So it will be the same. So even A plus B plus C are expected to put the same 30 bricks to complete the work. This is the time, this is the total work to be done, and finally the work rate. So I know the time taken by A to complete 30 bricks. The total work is 30 bricks. So what is the work rate? Work done by time taken. Right, that is 30 by 10. So he will be putting 3 bricks every day. That is the work rate of A. Similarly, work rate of B would be 30 by 15. That is 2 bricks per day. And C would be 30 bricks in 30 days. That's basically he's putting 1 brick per day. When all 3 of them are working together, A, B and C, in that time frame, that is one day, A will be putting 3 bricks, B will be putting 2 bricks and C will be putting 1 brick. So together they will be putting 6 bricks per day. Right? That is the work rate of A and B and C together. So now I know this, the work rate of ABC. I know the total work of ABC is 30 bricks. So what is the time taken? 30 by 6. Time taken by A plus B plus C. 30 by 6, that is basically 5 days. Now, this is how you will solve this question in a very easy manner. If you look at this, right, I assume total work to be 30. Let's take 100 for an example. 100 bricks, 100 bricks and 100 bricks. So if I take 100 bricks, what will be the work rate? 100 bricks put in 10 days. That will give me 10 bricks per day. That's the work rate of A. What about B? 100 bricks by 15. That's basically 5 3s there, 5 20s there. It will be 6.66 bricks per day. And this would be 100 by 30. That will be approximately 3.33 bricks per day. You see, if I take some 100, I am getting 6.66. I have to handle with the fractions which are not easy relatively. 3.33. Here it's lucky that 10 plus 6.66 plus 3.33 will turn out to be 20. So I can actually do it easier. But sometimes I might come up with the net being 16.66. Which is even harder to divide something by 100 by 16.66 will give me 6 times, but you have to be very quick with the decimals and all. So that's why logically if you take the LCM of them, you will always get integer values for this. Because I'm picking the LCM, there is no way that the work rates would be not integers. Once I get them integers, it's easy to add, it's easy to divide, multiply and play around with that. For that very reason, we always suggest you to calculate and assume the total work based on the LCM of this. Sometimes, this information would not be given in the question. Okay. In that case, you can't go ahead and do LCM, then assume 100 bricks or maybe something else, 50, 100. Generally, 100 would be maybe easier one. We prefer to take that. But it's up to you personally, whatever you find it easier. But if you get the days or the hours of each person, individual time to complete the work, you can always assume the total work to be something which is divisible by all of these days as the times. So that's why I take the LCM of them. So the other approaches is this: I assume the total work to be 1. That's one method. So what will be the work rate? It's 1 by 10. A will complete 1 by 10th of the work every day. B will complete 1 by 15. And C will complete 1 by 30. And then A plus B plus C will be 1 by 10 plus 1 by 15 plus 1 by 30. And I do it, the overall work rate will come to be 1 by 5. And he has to complete one unit of work. 1 by 1 by 5 will give me 5 days as the answer using the same formula. Work is 1 and the total work rate of A plus B plus C is 1 by 5, so it will come to be 5 days. Right? This is still slightly complicated according to me because you need to handle the fractions. Right? The other one is I'll take it as 100%. So A is completing, it's same as taking 100 bricks, there's no difference. Instead of bricks, it's like talking in percentages. So A will complete 10% every day, B will complete 6.66% every day, and C will complete 3.33% every day. Here you have to again deal with this non-integral values and handle that. So you'll get the same answer. The answer will not change irrespective of what you assume. 100, 1%, 100%, everything. It's just that we personally feel it's easier to take LCM values so that you always deal with the integers and go ahead and solve the question. So let's solve some problems to get a good understanding of this. What we recommend you is to pause the video, try these questions on your own, follow the explanation when we explain so that you get a good understanding of these concepts. Hope you have tried it. So let's look at the question. It's a very simple one. A can build a wall in 15 days and B in 20 days. So how much time will they take to complete the wall working together? So 15 days, B is taking 20 days. That's the time taken by them alone. Keep this in mind. They're taking 15 days to complete the entire work and B is taking 20 days to complete the entire work. Total work, I don't know, I'll assume. So I'll take LCM of 10 and 20. That's basically 20. So I'll take 15 and 20, right? My bad. LCM of 15 and 20 would be 60. So I'll take 60 bricks is my total work. So the work rate individually would be 60 bricks put in 15 days. That's basically 4 bricks per day. 60 bricks put in 20 days. That's basically 3 bricks per day. When they work together, it's basically putting 7 bricks per day, and the work to be done is still 60 bricks. So the time they will take together, 60 bricks to be put at the rate of 7 bricks per day. So that will be 60 by 7 days. Right, so this will turn out to be approximately 8 point something. So 8.5 something, 0.57. So you see, so this is how you'll solve this. We've already done slightly complex ones than this as well in the earlier examples, like 3 people working on the same work and with the negative and stuff like that. So I hope you would have solved this with much ease.